Hey everyone, and welcome back. In this lecture, we're going to take a look at how to customize and style our plots. We'll cover the majority of the most common and helpful styling options. So let's go ahead and move over into Jupyter Notebook and get started. Okay, so here we are in Jupyter Notebook. For this lecture, as there's a lot of typing involved, and we'll mostly just be looking at a few different examples, I'll actually just work through the notebook file that I've already created. If you want to follow along, you can find the notebook file here within the section folder. We'll start off by looking at some of the different color types available inside of Matplotlib. To start with, we have our base colors, which we've already looked at some of these, such as blue, green, and red, which we could abbreviate to B, G, and so on. And then additionally, all of the main CSS color options are available too. And there's a list of all of the different options here. For an even greater level of customization, we also have the option of using hex color values too. And I've linked a color picking website here so that you can go and choose a color and then copy its hex value to paste back into your Jupyter Notebook. We also have the option to customize our line styles and markers too. For this example, I've created a line plot using some data on product sales for different months, as we can see from the example chart below. But then I've also provided a whole bunch of different styling options. So let's go through and have a look at each of these now. First, we have the color, which we're already familiar with, and this just lets us modify the color of our line or chart. We could set this to any of the color options that we've just looked at. So for instance, looking at our CSS color options here, I could change this to dark violet or even a hex value if I wanted. Then we could change the line style, and I've set it here to be dashed, as well as changing the width to 3 to make it a little bit thicker. And there's a load of different line styles available, so instead of going through all of them now, I provided you with a link to the Matplotlib website with the documentation for the line styles, so that you can see all the options available. Next up, we have quite a few different options available for our markers. I start here by setting our marker to be an O, and then we just change various components of this, like the size, face color, face width, and edge color, which changes the formatting of our actual marker points, as we can see from the example below. If you're interested in having a look at some of the different marker styles and options available, I've also included another link here to the documentation for the marker styles. As we can see here, that is a lot of different options. We're also able to customize our axes and axes labels too. So like before, when we set our axes labels with plt.x label and plt.y label, we also have the option of providing these with some additional arguments to customize them too. To start off, the first argument is just the label itself, which I set to month, but then I change things like the font weight to bold, and then change the font size too. And then I've just gone ahead and done the same for our Y label and our title. A lot more detail on the font and text customization options can be found again in the official Matplotlib documentation, which is linked here if you'd like to have a further look into these options. But as mentioned, I'll just cover the most common and most useful of these in this lecture. We can take this a step further and even customize our tick labels as well. So here, I've set the font size to 12, just to make them a little larger, and then also for our X label ticks, I rotated them by 45 degrees, which just helps to add a little bit of separation and visual change to our plot. And then here, I've also changed the styling for our grid too. So using the plt.grid function, I've just changed the color, style, and width of our lines to be grey, dashed, and a little thinner. And then finally, at the bottom here, I've called the plt.tightLayout function, and this is used to ensure that the plot fits nicely onto the canvas by automatically adjusting the spacing and sizing of our different chart elements. This is usually used when working with figure objects and subplots as part of the object-oriented approach to Matplotlib, which we'll have a look at in the next lecture. But even for the functional approach, it usually results in a much cleaner and nicer look overall. And then this here at the bottom is just the result of our plot with all of the customizations and styling applied. Just to quickly show you, this is what our plot looks like without the tight layout function. The difference in this case is quite subtle, but it does look a little neater overall due to the extra spacing that it adds over here off to the right. Okay, and then the final thing that I'd like to show you in this lecture is how we can go about adding multiple plots to a chart, as well as adding in a legend to help us identify these different plots. For this example, I'm using the same sales product 1 variable that we used last time, but then I've also gone ahead and created another product called sales product 2 with a different number of sales. To plot both of these at the same time, all I've done is go ahead and call two plot functions. So we've got our first plot here for our sales product 1, and then all of the associated styling options that we've just looked at. But then below this, I've also added in another plot, which I've actually set to plot our sales product 2. And then I've also changed the styling of this to make it different visually too. So with a different color and then a different marker too. But an important change here though, is that I've actually added in another argument at the end, which is the label argument. For our first product, I've set the label to be product 1, and then for our second product, I've set the label to be product 2. And this will be very important for when we come to create our legend, which I'll show you now. To add in a legend, all we have to do is firstly, as we've just seen, add in our label argument to our plot functions, and then when we've done this, we can just call the plt.legend function. And this function doesn't actually need any arguments, but if you want to, you can pass in the loc or LOC argument like I've done here, and this lets us manually choose the location of where to position our legend. If you leave this blank, then Matplotlib will automatically determine where to place it for you. But to specify a location, we can use either location strings or a location code. And we can see a list of all these options here. So in this example, I just set my location to be the upper left, which has a location code of 2. So we could just say that this is equal to 2, and that would have the same effect. The default value for this argument is 0, and this is where Matplotlib will automatically determine the location for you. So by specifying any other location other than 0 or best, you get to decide where to place it yourself. And then looking at our output, we have our two products, but plotted at the same time on the same graph, with the different styling applied, as well as the legend in the top left, showing us what each line represents. Okay, and that's it for our lecture on how to customize and style plots inside of Matplotlib. In the next lecture, we'll have a look at the object-oriented approach to Matplotlib that I've mentioned earlier on. This is usually seen as a better approach than the functional approach, as it allows us a greater level of control and flexibility about how our plots are created. I hope this is making sense so far, Matplotlib does have quite an unintuitive syntax and commands, so if you've got any questions or need any help with anything, then please feel free to post down in the Q&A section below, and I'll get back to you. Thanks everyone, and I'll see you all in the next lecture.